Right everyone, my name is Deepak and I'm working at Nolder Software as a senior software consultant. Today I have come up with an interesting topic which is VAVR. So VAVR is nothing but a functional Java library. So come let's explore this. Alright, before we begin I want to talk about Nolder. Nolder is a team of passionate technologists with a product mindset who work along with the businesses to deliver solutions at the speed of competitive advantage. Our main capabilities are around reactive products, IoT, microservices and API, data science, data engineering, and DevOps. We also have our strategic partnerships with Databricks, Lightbend, Confluent, and many more to deliver more value to the clients. Alright, this is going to be our agenda for today's webinar. First, I will be talking about what is VAVR. Then we would be doing a quick comparison between Java 8 and Scala. And then I'll talk about VAVR module, what all do we have in the module itself. And then we would see how how VAVR library gels up with Java 8 and how we can actually use VAVR library with our Java 8 projects, and then we would be heading towards the VAVR demo. Alright, let's first talk about what is VAVR. VAVR is essentially a functional Java library which aims to extend the features of Java 8 and helps to reduce the amount of code and increase code quality. It also provides collections, function interfaces for error handling, concurrent programming, and pattern matching. There are many other modules which revolves around VAVR core. So we will be exploring VAVR core module, which has got features like persistent collections, immutable collections, and new functional interfaces for error handling, concurrent programming, and pattern matching, of course. So we'll talk more about VAVR when we would be doing a quick comparison between Java 8 and Scala, and we'll see why do we need a functional Java library like this. Okay, so let's first see what are going to be our prerequisite for VAVR. So VAVR, for using VAVR, to start using VAVR, what we need is Java 8 or above, and we also need a build tool which can be Maven or Gradle. So when we've got both of these, we can actually start to use VAVR library. Okay, now we want to do a quick comparison between Java 8 and Scala. Okay, so we'll do a direct comparison between Java 8 and Scala to understand why do we need a functional Java library to make things better. Okay, we already know that we have a Scala already in place, and which is known for functional programming, of course. So when Java 8 was introduced in 2014, so we were very hopeful that we would get to use functional programming in Java as well, because prior to Java 8 Java was not functional, of course, right? But then when Java 8 was introduced, we were very hopeful and it worked really well. But when we compare it directly with Scala, it still lacks a lot of feature which are still not there in Java, right? So we'll see those features with the help of this VAVR library. So by using VAVR library with our Java 8 projects, we can get features similar to Scala. So we will also do a quick comparison between the Scala and Java 8. So what I'm trying to say is, if you want to have similar kind of feature which are already there in Scala, right, with Java, right? You are a Java developer and you want to use features similar to Scala. What you can do, so you can incorporate this Vavr library, and by incorporating this Vavr library in your Java 8 projects, you can get features similar to Scala. So what all features which are there in Vavr? Let's see those features one by one. And by using this library Vavr, you can actually enhance your functional programming experience, right? So that's what we want to do. Alright, inside Vavr module we have got a lot of things. So first we will see tuples. So we already know that we do not have tuples in Java 8 yet, right? So with the help of this Vavr library, we will be getting all these features, of course. So we'll talk about tuples, we'll talk about functions. Okay, function, we do have functions already in Java 8, but these function interfaces in Vavr module are somewhat different from the ones we have in Java 8. Then we will see what are values. We'll also see futures are already there in Java 8, but then we'll see what different how different it is from the normal futures of Java 8. And we also have functional data structures and collections. All right, so of course we do not have functional persistent data structure in Java 8. The collections in Java 8, the list and all, they are still mutable. So by using this library we'll get the immutable collection, so we'll talk about those as well in the coming slides. Alright, so first let's see what are tuples. Okay, so you must have seen tuples in Scala if you have ever worked on Scala. It's okay if you have not worked on Scala, but okay, let me just quickly read this for you. So tuple is nothing but a data structure which will have a fixed number of elements and can hold objects of heterogeneous types. That means it can hold objects of different types. So you want to have a tuple of an integer value and a string value, so that is quite possible. So if you can look at the screenshot here, I have a tuple demo. We'll also look at this tuple demo in our demo as well, but just to give you a quick overview of tuple. So here I have got a tuple object which is holding two different elements, two elements of different types, so similar types, sorry, integer and integer. So I've got two values. So prior to this it was not in Java it was not possible without this library to return a tuple value. So but here we can do that, right? So next is functions. So in Java 8 we have functions which accepts one parameter, right? And then similarly we have got buy functions, consumer, supplier. So these are all functional interfaces, right? And and buy function which accepts two parameters and gives output, whereas Vavr provides function with up to a limit of 8 parameters. Okay, so in Vavr we already have function interfaces which can accept 8 parameters, right? And give you a result, of course, right? So we already have a built-in function interfaces which are there for us. So instead of creating our own function interfaces, we can quickly go and start to use these function interfaces which are already there in place. So here as you can see on the screen, I have got this function 2 function which will basically take two inputs and return an output, right? So similarly, I can have function 8 which will take 8 parameters, right, and return an output, right? So that was all about functions. Okay. So now next is values. So inside values we have got a lot of things. So we have got options. Okay, for option we have something similar in Java 8 which is called optional. So optional, you can compare option with optionals, right? So there is hardly any difference. So the only difference is about the methods these classes have, right? Then we have got try is not there in Java 8, but it was there in Scala. Similarly, lazy, either, these were the things which are already there in Scala, but they are missing in Java 8. But if you want to have these features in Java 8, then of course you have to use this library, right? Then we have got collections. So when I talk about collection, these collections are immutable collections. Then we also have got pattern matching. Okay, a quick update in Java 14, we now have pattern matching already in place. So if you have not if you guys are not aware of that, but it's a quick update. We have got pattern matching now in place. So when we talk about Java 14, so with the help of instance of, we can start to use pattern matching in Java 14 as well. But what if you want to use pattern matching in Java 8? So VAVR is your solution, right? Okay, what values are? Let's see. An expression which can further be evaluated for calculation or other is R values. Basically, in Java this can be expressed by making the state of an object final and call it immutable. So VAVR's function value abstracts over immutable objects. So when we talk about functional programming, we want to have immutable objects, of course, right? So if a variable and objects are immutable, their state is unmodifiable, unchangeable, and which provides thread safety. So these are the basics and fundamentals of functional programming. So we can share the variable without any fear in a multi-threaded environment. So these are the basics, right? So value is nothing but an expression for us, right? So every expression is a value for us. So let's see what we have got in values. So first we will be talking about option, right? We saw option in Scala language already. However, in Java 8 something similar was introduced with the help of optional classes, which behaves pretty much similar to Scala's option, which is true to some extent. Like I said, the only difference is about the methods we have in both the classes. So instances of option are either an instance of some or none. Honestly speaking, I don't see much difference in Scala's option and Java's option. That is correct. I mean, like, there is no difference as such in the implementation. So what we want to achieve here is we want to see if the value is present or not, right? And based on that we want to take some action. So this is quite similar to optional, right? Optional in Java 8. So the only difference is it looks similar to Scala's option. So in Scala's option we have got some and none. So if the value is present, it will have some value, and if the value is absent, it will not have any value, which is none, right? And all other methods are pretty much similar, like get or else, if the value is present or not. So these are the methods which we are calling on an option object, right? So this works pretty much similar. Okay, next is try. So try is nothing but a container that represents a computation that may either result in an exception or return a value. So this looks so what will happen is I want to try some value. So if the value will be present, I will get the result, or this result will be in the form of success. And if the value is if if something something happens, something wrong happens, and in that case what I'll be getting is an exception, and I won't be getting any value for that if something goes wrong, right? And so you must be wondering, this looks similar to either, but it is different than that. Of course, instances of try are either success or failure, so this is the difference. And if you want to explore the difference between try and either, so either would be coming in the coming slide, so we'll see the difference, then we'll also talk about the difference between either and try. So for now, let's focus on try. So try okay, how we can create a try object. So for that we have got static factory method, which is off. So with the help of try class, we would call this method off and try to create the try object. So if everything is fine, and so if everything is fine inside the try, so it would generate a successful result, right? And if something goes wrong, it will result in failure. So as you can see in the screenshot, so first what I'm trying to do is I'm trying to divide a number with 0. So of course this would return an exception, and it would result into a failure. So what I'm trying to do is, here I'm trying to show you the failure. And if everything is okay, and if I try to divide the number, if I try to divide the number with 1 or some other values, I mean the value other than 0, it would result in success and would give me the success result, right? And the success result I can obviously call the get method to get the value. So first I can check if the instance is of type success or not. So once it is the type of success, then of course I can call get on this, so that I get the value. Because if I try to call the get method on failure, then obviously I would be getting some exception, right? So why do we want to use try? So when we are not sure about our value, and that value might return, that expression might return some exception, then probably we want to use try, right? Okay, the next is a lazy. Lazy is a container which will represent a lazily evaluated value, right? So when we say lazily evaluated, we mean that the value will not be evaluated until and unless it is called, right? So the value will not be executed at all. So once it is once it is called, only then it will be evaluated. Alright, so lazy is memoized already. When I say memoized, it is it means it is cached, right, internally. So it evaluates only once, and next time onward returns from a cache. So once it is evaluated already, the next time you try to get the value, it will return the value from cache. So we are not going to talk about the internal implementation of the lazy object, so how things are memoized and all that, but we'll definitely see how lazy works. So let's see, as you can see on your screen, we have a screenshot. So what we are trying to do is, we have got two variables over here. One is first and the other one is second, right? So we are trying to create a lazy object. So with the help of this abstract factory method, static factory method of, we are creating a lazy object, right? So uh, in the first println statement, we are trying to see if the value is evaluated or not, and you can see in the comment that it says false. Why false? Because this is a lazy object, right? So it is not evaluated yet because I have not called the function yet. So once I'll call the function and once it is executed, only then it will be evaluated. So in the so in the second print statement, I'm saying sum dot get. So when I say sum dot get, it is now evaluated, right? So I have called the function already, and in the next println statement, when I say is evaluated again, so it now says true. Why? Because I have called the function already, right? So now it is evaluated finally. And in the last print statement, when I say sum dot get, right, so it returns the result again, but this time it is returning the response or the result from cache, right? Okay, next is either. So either is an instance of left or right. Okay, a common use of either is as an alternative to option for dealing with possible missing values. Okay, we were also okay, a common use of either is as an alternative to option for dealing with possible missing values. Okay, what happens is when we use option, so in the default value, what we can do is we can only return the same type of value which otherwise would be present, right? So in the default value, you are not allowed to return the value of any other type other than the value you have presented otherwise, right? So all right, you can relate it to option as well. So left is considered to be none type and right is considered to be some type. Instance right will hold success and left will hold failure. So in the left you will have the failure case and in the right you will have the success case. Okay, so as you can see in either I have this string and integer value, right? So in the left I have string value and the right I have the integer value. So I have created one function called function with either. So if integers okay, if integers is right, okay, so if it is right, so I want to return the value from integer, right? And else I would say integers dot get left. So now I know that the right value is not present. So in that case, what I want to do is I want to get the left value. So similarly, I have created a function. So I say in the function, if number is greater than 0, either I want to create either dot right with number. Otherwise, I would just say either dot left, please input a valid number. So if you can see the difference, like I said, I want to use either in place of option, but when you would be using option, so let's say you have created an option of integer, right? So if the value is not present in the default value, you are only allowed to pass a default value which would be an integer object only, right? So you cannot have a string object for option integer, right? Which is correct, but this is not the case here. When you're using either, what I'm doing is in the default value I'm not using an integer, I'm using string. So the type can change, right? So we can have different types for default values, right? All right, next is future. A future basically represents the result of an asynchronous computation. When the asynchronous task is created, a future object is returned. So there is a get with future which will complete the result from future, but it is blocking, of course, in nature. It also has is complete, which returns a boolean value to mention if a future has been completed. So a future will have two states, of course. One would be pending and the other one would be completed, right? And so if you ask me, I have not been a great fan of future, which comes with the Vavr library, because Java 8's future library is already is already rich enough, and it has got a lot of potential. It has got a number of callbacks methods which are really which are absolutely great to use, right? So I have not used futures from Vavr library much, because I don't see any you know I don't see a great use of futures of Vavr library. Okay, as I said, there would be two states: pending, the computation is ongoing, a pending future may be completed sometime later or cancelled. Completed means the computation finished successfully with the result, failed with an exception or cancel. I would again suggest to use future from Java 8 only. Okay, this we have already seen. Okay, I was going back, I'm sorry. So this is done. Okay, now let's talk about the collections and functional data structure. Function data structures we have. So in Vavr library, a new collection library has been introduced to meet the functional requirements, which are of course immutable in nature. So in Java 8, again the list is again mutable. They are still not immutable, but when we talk about function programming, we are talking about immutable objects, right? So that's what we said in the very beginning, and this is true, of course, right? So if I want to if I am working with function programming, I want to have the immutable object, but then list is not immutable. So how do I go about this? So we can have this Vavr library incorporated in our projects, and we can have the immutable collections already. And right, so Vavr library will essentially reduce the boilerplate code which we will see going forward. This new collection is essentially based on java.lang.iterable only, and list in Vavr Vavr list is essentially an immutable list. So mutation will result in new instances, of course. And apart from list, we also have got queues, sorted sets, and tuples, which we have already seen, right? And so we'll talk about these collections in the demo itself. Okay, next is this is a very good feature. We have talked about this already. So pattern matching is there. Pattern matching is a great feature from Scala, which was missing in Java 8, but then in Java 8 we did not have this feature, of course, but in Java 14, which is going to be Java 14 is going to be released in March only, right? So in Java 14 we do have pattern matching, right? So with the use of instance of, we can use pattern matching, right? So but yeah, if you're not using Java 14 yet, right, and you're still using Java 8 and you want to do pattern matching, how would you do that, right? So this is the question. So with the help of this library, of course, you'll be able to do pattern matching. It's still not that great when I directly compare it with Scala, but then the basic is there, right? So you can start to use pattern matching. We'll see that in the demo, right? So pattern matching was not introduced as part of Java 8, although we have worked with pattern matching in Scala, but Java never had it. That is true. And Vavr library has support for pattern matching. Now you can also use pattern matching in Java 8. That is true again. So in pattern matching, match is essentially an expression. So we'll see that what is match is an expression which yields some result. Also, pattern matching is really a great feature to save a lot of time, as it avoids to write if else branches and the code looks more clean and readable. Obviously, I mean, like, if you have worked with pattern matching in Scala ever, so of course, so we can avoid these if else blocks which looks very clumsy sometimes, and we can dramatically reduce the line of code, and also the code will look more clean and readable to the user or the developer. Okay, now let's do a quick demo of Vavr with Java 8. So for that, I'm going to open the project on IntelliJ. So I have got the demo for each. Okay, we will start with tuple. Right, so tuple demo is here. We have already seen this. What I'm trying to do is I'm trying to create a tuple 2. Tuple 2. So it will take so tuple 2. So okay, how can I create a tuple object? So this static factory method of, with the help of this static factory method, I can create the tuples. And if I want to retrieve the first value from the tuple, so how can I do that? I would just simply say dot underscore 1. This will get me the first value. So in my case it is going to be 1, and this is going to be 2. Alright, if I also have created a tuple object with 2 elements of same type, string. Alright, so this is working. Let's quickly see if I can have tuple with different types of value. I want to have 1, and then I will debug. Okay, let me just print debug underscore 2. This should give me debug. Right, let me just quickly run this method. It's taking some time to build. Okay, this says debug. Alright, so this is working fine. I mean, in tuple you can have heterogeneous types as well. That is, you can have elements of different type. So tuple is, so with the help of this static factory method, you can create tuple objects, right? So next is function. So we have got this so this function interface, function2 is already there. So when I say function2, so it takes two parameters and return one. So it is a function interface. If you go and take a look, this is a function interface, right? It has got a lot of additional methods as well. So okay, so if you want to have a function interface which takes 3 parameter and returns an output in Java 8, of course that is not possible because we do not have a function interface like that. Similarly, if you want to have a function interface which takes 8 parameter and returns one output, that is also not possible in Java 8. But then again, you can create custom function interfaces, but then with the user behavior you don't have to do that, right? So you already have function interface which takes up to 8 parameters and returns the value. So these function works just similar to the ones we have, the functions we have in Java 8, right? So there is nothing different about them. And okay, next is we have options. So option we have already seen. So first we are creating option of null, and then we are creating option of sum, option of none. So this first value will of course result in the null pointer, and the second value will get the second this would get me some value which is Deepak, of course, because the value is present, and the second one would result in default name because the value is not present. Let me just quickly run this. So with this static factory method sum, we can create the option object with some value, and this abstract factory none we can create the option object with no value. All right. Okay, so first one, I'm very sorry, first one would not create the null pointer error. So if null is there inside option dot off, it would create it in a none type. So this is also great. So if if you are calling some function and you are not sure whether it is going to result in null or would result in some value, then you can wrap this value in off, right? So that would help. Next is lazy. Let's see lazy. Okay, as you can see, I have created a lazy object with the help of this static factory method off. So I'm creating the lazy object with type string. So when I say name.get, it would get me the value. Okay, let me just do it this way. If I say name.isEvaluated, it is going to return false because I have not called the object, so it is not executed yet. So isEvaluated should return false, and once it is called, isEvaluated would return in false. And then finally, as I said, lazy objects are memwise. That is, the next time we call lazy objects, they are going to give you the result from cache. So let me just call this. Okay, the first one is says false, obviously, and then in the second println statement, I get the value from the object itself, and then is evaluated true because I have called the object already, and the second time it gets the value from cache itself, right? And okay, let's see the try. Okay, in try, what I'm going to do is I'm having a function which takes two parameters and it gives me a result. So let me just create the try object with this abstract factory method of. So when I say divide or apply 5 divided by 0, then I know obviously it is going to return an exception which is divide by 0. So I want to see what happens. So this is a failure and this is a success because, okay, let me just quickly run this one. So yeah, so this is a failure case with the exception, right? But it has not actually generated an exception. Had this been a normal expression, it would have generated some exception, but here it has not generated any exception. It has returned a failure object which is wrapping the arithmetic exception basically. So you have got two instances, one is success and the failure. Okay, similarly then next is we have got either. So either, as I mentioned, you can use either in place of option when you want to have the different type of value in the if you want to return different type of value in the case of fallback or default value. Of course that is not possible with options, so you need to have a similar type of value in default method as well. But then in either that is quite possible. So you have created either object, right? So for that I have got a function. So in the left I have a string object. So if something goes wrong, it will return a string object, and if everything is right, it is going to return the right case, which would result in some value. So if integers dot is right, so I'm going to get the value. If I know that it is not right, so I am just going to get the left value, which would result in some integer, that is please input a valid number. So that is how we create either, right? And which functions we have already seen. So future, as I said, futures are not that great from function Java library, but again I mean, like, we can at least see how future objects are created. Okay, there's something wrong. Okay, it is now open. So okay, so this, with the help of this static factory method of, we can create the future objects, and then when I use get method, I can get the value of the future. But we should not be using this get method because it is blocking, of course. But then to show you the result, I have to use it now. So this returns me 2, right? Of course, because I'm returning it to an integer object with the value 2, right? So this is how we create future, but then it's not that great. So I recommend not to use future from the VAVR library. You can use the normal future library from Java 8, which is completable future and completion stage, right? And okay, so next is collection. Okay, let me just quickly take you through list. Okay, if you can see in Java 8 how do we do. So okay, let's not just talk about this. And okay, for this one, okay, how do we create a list? in how do we create list in the Vavr. So this static factory method of you can create the list. The only difference between this list and the Java 8's list is that this list is going to be immutable. How? Let's see. So here what I'm doing is I am creating a list with some elements. So I have got 5 elements, 1 2 3 4 5, and then I'm going to print this list. So this is going to print 1 2 3 4 5, of course, and then what I'm going to do is of dot append 6, right? So here I'm trying to append one more value, 6. So what do you expect? So this list should grow to 6 elements and 6 should be appended at the end. Alright, so what do you think this would happen? I'm saying this won't happen because this list is immutable. If this list is immutable, so the state would not be changed, right? Let me just run this. So it should be 1 2 3 4 5 at the end. Exactly, this is 1 2 3 4 5. If I want to have the result, so I'll need to store this in a new list, new reference, right? I need to use new reference, and when I print this new reference, the change should reflect. It should have 1 2 3 4 5 6. So this shows, right? This thing shows that list in Vavr are immutable, right? Okay, next is pattern matching. So pattern matching is a very popular feature in Scala, but it was never there in Java 8. But if you want to use it, so how would you? So again, you have got this static factory method of, and you have got this match class. So in this match class, you would be entering your input, and this input would be checked against all the cases we have, and in the pattern matching, and the result would be returned, right? For case 1 it would return 1, for case 2 it is going to return 2, and for default value it would return false. So what we are expecting here is we are expecting a string object, right? So when I say this number, it would result in 2. So similarly we have got this conditional pattern matching, wherein what we are doing is we are trying to have a condition that if case is 1, right? So I want to return this, right? Similarly, if I have got case is 2, so similarly we can have different types of condition here, right? So this would result in the different value. So if I run this, it says 2 for the first, because I have input 2 and it should go here, and for the second I'm trying to have the condition where it should go in is. So what I'm doing is 1, and I would basically have the value of the conditional value, which is 1 in our case, right? So it would result in 1 followed by numeric 1. So this is the basic pattern matching we can do using Vavr. Alright, so this was all about the demo for Vavr. Alright, and Thank you very much. So if you have got if you've got any feedback or questions for me, you can write back to me. Okay, so these are my these are my contact details. So this is my Twitter handle, which is at the rate deeps underscore 1991. So you can leave a message on Twitter. You can write me at my email ID, which is deepak.mehra@noldus.com, and you can also leave feedback or your questions on LinkedIn. So these are going to be my contact details. If you want to reach me out, you can reach me out on any of these platforms, right? And also, if you want to learn more about VAVR, if you want to explore more on VAVR, I have written quite a few blogs on VAVR. You can check those out. So what you need to do is you just need to write blog.noldus.com followed by my name on Google, right? You will see all the blogs by me on VAVR. And if you want to explore more blogs on VAVR itself, so you can just simply go to blogs.noldus.com and you can look for author Deepak Mehra there, and you would be able to see all the blogs on VAVR from me, right? If you want to explore more on VAVR. I think that's all from my side, right? Thank you very much for watching. Bye bye.